Good evening, everyone. Today, we'll be presenting about regression models as a part of Introduction to Machine Learning. I am Keerthana Murali, and my fellow speaker, Shambhavi Singh, is here with me today. So we'll be covering single linear regression and multiple linear regression. Coming to single linear regression, it is a statistical method that is used to. So one is the independent variable and the other is the dependent variable. Independent variable is our feature variable that we use to predict the target variable. So this is the equation for single linear regression. Typically, single linear regression is a line. So we have the y is equal to mx plus c format. So yi is our predicted value, and B naught is the estimate of the regression intercept. B1 is the estimate of the observation I. Multiple linear regression. So this models the relationship between multiple independent variables and a single dependent variable, which is our target variable. So independent variables are called features or X, and the dependent variables are target or Y. So this is the equation that we use to model multiple linear regression. So we have multiple slopes for the multiple feature values. I will be talking about the univariate feature selection in our mini project. So moving on to our code. Now Shambhavi will be explaining about the single linear regression project.
So in case of single linear regression, you just have one attribute. So as we said, linear regression is used to correlate between a dependent and an independent, between independent and dependent data. So here the independent variable we are assessing is the area, and the dependent variable is the price. What it means that your area, as it keeps changing, your price will keep changing based on that. If you have 1 acre land, the price will be 1 crore, supposedly. If you have 2 acres, the price will change to 2 crores. So the area is the independent variable, price is the dependent variable. Before that, we import all the libraries, NumPy, Pandas, sklearn, etc. And then we create a data frame first. And before that, we need the data set. So here's the data set. If you need the link to download the data set, it's here. You can go to this link and just download the data set. It's an Excel sheet. So once you have downloaded the Excel sheet from here, you got to go to the table of contents part, go to this place, and then click on upload to session storage. And the Excel sheet that you have downloaded, just upload it to this area and wait for it to upload. It should be named housing.csv. Once it's uploaded, create the data frame. And when you look at the file, the CSV file, it has 545 entries. And then there are these many attributes. Attributes are basically the columns. And for single linear regression, we'll be choosing only one attribute. So the independent attribute, the independent variable will be the area, and dependent attribute is the price. Now extracting the features and target variables, that is assigning x vector to area and y to price. And now we will split the training and testing data set. Now, whenever you're creating an ML model, you're using an ML model, there are two things that you use: training data and testing data. And from the data set that you have, you can divide the training that all the data present in there in two ratios. Basically 80-20 is a good ratio. 80% of the data that you had can go into training, and 20% of the data you had can go into testing. So here, this is the X train, Y train data, and next test, Y test will be used for testing. And you are splitting it into using X and Y that we defined here. Test size is 0.2, meaning the test data is 20% of the all the data we have, and random state 42. That means it will keep only a arrangement of data that you are taking into 80 and 20. If you put random state equal to 43, it will randomly select 80-20% of data, but uh, it will separate. It will separate them differently, so the content is different later. So this is our X train, and this is the testing data. You may see training data is 436 rows, but testing data is 9 rows. So training data is more, 80%. Testing data is less, 20%. And data is this. Testing data is this. Now you create a linear regression model. Now we create a linear regression model using linear regression, and we assign the variable model to it. And then we use the training data that we have to train the model. So now the model keeps taking values of area from the training data we had, that is the 80% of the data from the original data set. It will keep fitting it into this linear regressions equation, and whatever result it gets, it will check with the housing prices that it has. That's the Y train. It'll keep checking from area to the price if whatever it has predicted is matching the price that we have. So that's what it's doing during the training. And now it's testing it, so it will make predictions. So from the 20% data that we had, we will enter that into the model that we have now. So it will go in the model.predict X test. And now the Y predicted will be the values that are coming out of it. And it will the model will keep testing this Y predicted values, that is all of these, against the values that it already in that other 20% data, the pricing. And now comes the evaluation of the model part. Um, so it basically gives you places a metric on how you may evaluate your model. You got to know how well your model will predict something, and that's what we are doing here. So for different types of regression or different ML models, there are different evaluation metrics. For classification, you had accuracy, precision, recall, and stuff. But for regression, you have mean squared error, mean absolute error, and R score, R squared error. So talking about them, when you have a lower MSC, your model has a better performance. And our MSC here is this is the MSC, and then the mean absolute error, the lower the MAE, the better the model. And the inverse is inverse works for the R squared, R score. And then when you visualize the model, so basically for linear regression, for this one, we are basically predicting a single line that best fits the outputs that we are getting. So for all the area that we have put in here, we have predicted these many price, and most of the prices that fit in here fit in this through this line. So that's what we were trying to predict. And based on that, if now you randomly put some area, say 6,500, and then you fit it into this line, you have determined an intercept, you have determined a slope, and now your X will be n is 6,500. And now the equation that you have gotten will predict the price of that 6,500 square foot area. So so if you put here 2000 from put using the model that you have, the price it is giving is 33 lakhs 63,713, etc. So yeah, that would be all for single linear regression. Multiple linear regression will be handled by Keerthana.
So we import some of the common libraries that are used in machine learning, like NumPy, Pandas, Matplotlib, scikit-learn, and so on. So let's quickly run that. Now, in order to import the data set, we use the read_CSV command. So our data set has around 13 features, out of which one feature is the target variable, which is price. Out of the remaining 12 features, we don't use all the features for our multiple regression model, because more than the quantity of we need qualitative features, only the ones that are, that really decide what the target value or our price will be. So we use univariate encoding to select the top best features. First, we get rid of the dummy categorical variables, because we cannot apply this method on categorical values, so we convert them into numerical values. And then we drop the price column, because price is our target feature. So in this univariate method, we make use of select k best class and f_, which calculates f values between the price and the remaining 12 features. So based on these f values, you select your top features. And the top features from our data set are area, bathrooms, and the air conditioning. So in our multiple regression model, we use these three features to predict what our price will be. So we feed the selected features into X, or independent variable, and our price column into Y, or the target variable. And I've just plotted these values so that you can, visualize. So this is the area versus price column. So categorical variable. Since we use the univariate method, we were able to convert it into a numerical value. And that's why, even in the scatter plot, we get columns like these. Same applies for air conditioning as well. So now it's time to train our data set. We split it in the ratio of 80:20. So, if you have 100 samples, 80 samples will be used for training your model. 20 samples will be used for testing your model. So that's what we are doing here. We have around 500 samples here. So 80% of that is being used for training our model. And then we fit our model into the training set. Now we use the model.predict function to, test it over our testing data set. And now we evaluate our model using the three most commonly used evaluation metrics: mean squared error, mean absolute error, and R-score. So, the higher the values mean squared error and mean absolute error are, it is not very good for your model. And for R-square, it is the opposite. So now we've found out our coefficients and intercept for our multiple linear regression model. The coefficients are 3.1, 1.43, and 1.15, and the intercept is nearly 9 lakhs. So this is how you implement multiple linear regression model to predict the price out of a given data set. That will be all for multiple linear regression. So, multiple linear regression, it is represented by this equation, right? So this B1, B2, and Bn are the coefficients, and B0 is the intercept. Y is your value that you need to predict, which is price. So this is just a mathematical equation. When you, substitute those intercept and coefficient values, and for x1 you put the area value, x2 you put the air conditioning value, and x3 you put the bathroom value, you get your price. It's just like solving a mathematical equation. So that's why we have to calculate the coefficients and intercept.
Like for every model that you run, you'll have a different intercept and coefficients. So when you're running a model, you already have some pre-given data, right? Based on what data you have previously, the model is going to create coefficients. So the intercept or the bias has to be calculated by the model. And while you are putting inputs, each input will be put in with a weight. That weight you have to calculate using these coefficients. And for each model you run, each data you have from before, the weight and the intercept will be different. And that sets the end result of the model. So yeah, that's why you're getting calculating all the coefficients intercept.
Regression, there are multiple types of regression. So there's also non-linear regression, which you can use for, predicting stock prices and all. The basic difference I would say is you can represent linear regression with a straight line, and for polynomial or non-linear regression, it is a curve, or it can take any shape. So that's the main difference. Any other questions? Okay, there are various ways to, calculate how your columns, your features are related to your target values. So in this case, price and the other features are there, right? You have your bathroom areas, the area size. So there are methods like feature selection and multiple other ways that you can calculate if it's linearly related or non-linearly related. You also can apply correlation analysis to find this.
Okay, then that would be all for today. Thank you so much for joining.